Who the man? Who the man? Who the man? Who the man?
Plus sign, multiply, subtract, and divide. Get math in your mind, then you'll see your dollars rise. Teachers have your kids play video games, cause it helps to get the math facts into the brain. Simple and plain, we educate with minimal strain. Have fun, everybody now, isn't it great? Try some long division today, we just give it away. No time limits, you can.
Hey, it's Mr. Miller and Mr. Lewis. It's the end of the day today. Man, we're going to burn through this. This is going to be a quick one. Hang on. Hang on to your box plots.
Yeah, you
How
say a
doing?
quick one every time.
I know, but then I get into the math and I start digging it, and it's all good.
All right, here we go. Last one on box plots.
I did hear of some stats lectures who are an hour and a half long.
And they haven't experienced that.
Okay, anyway, this is not going to be that long. We want to do 4 different kinds of problems. So some are review and some are previewing a little bit what we're going to talk about tomorrow or the next day. The first one is construct a modified box plot. We've done this in class, but it has several steps, and it's easy to kind of get lost here a little bit. You might want to pause and try this on your own if you want. The data is right there. See if you agree with what we get. We're going to step through it very quickly, though. So the first step, we're still kind of doing this partly by hand, is to enter the data and use one variable stats to find the 5-number summary. So we did that. Mr. Lewis, you ready?
I am good. Where are we?
All right. The minimum is 64,
64?
right? No, I'm sorry, 30.
No? Okay. I was going to say.
I just gave away a problem, too. Q1 is 41.
41?
The median is 43.
43.
Q3 is 48.
48.
And the max is 50.
50.
If you just wanted a regular box plot,
0.
this would do it. Those are the 5 numbers we need for a regular box plot. But we are super duper AP students. We put in outliers. All right, so
That's true.
we have to find the lower fence and upper fence. So lower fence, the formula is there this time. Look at that beautiful printing
That
I
is,
did this time,
that is
right?
great.
I know, big improvement.
You're a great typist.
Q1 minus 1.5 times the IQR, so I'm on it. So it'd be 41 minus 1.5 times the IQR is 7.
7.
So the lower fence is 30.5. Ooh, we do have at least one outlier because we have a 30. Okay. The
Yep.
upper fence is Q3 plus 1.5 times the IQR. The upper fence is 58.5. So no outliers on the upper side, but we have outliers on the lower side. Okay, so there are a lot of ways you can do this, but here's 3 easy steps. Draw the box. So,
Okay.
Mr. Lewis, label Q1.
Q1.
Median is 43.
43.
And Q3 is 48.
48.
Look at that. So middle half of
Boxed.
the data is in there. So that's the box first.
Q3.
And the next part is extend the whiskers. The upper whisker is the easiest. It goes all the way to the max because there's no outliers there. Now we have to do a little thinking. We have to find the lowest value that's not an outlier. So that last 30, circle that up there. Could you in the data? That's an outlier. We got to find the smallest value that's not an outlier. I see a 36. You see anything lower, Mr. Lewis?
I do not. I think we have a couple 36s, 37. Yeah, 36 is our guy.
Okay, so go down to 36. That's the lowest value that's not an outlier. And then we're going to mark the outlier at 30. That's the tricky part of the modified box plot is how to draw the whiskers. So it's as if we took the outliers out and drew a regular box plot. The whisker goes down to the lowest value that's not an outlier. Okay, so very good. There's our modified box plot. Mr. Lewis,
All right.
professional. All right, here we go. So this time we're going to go TI-84 all the way. This is going to be real quick. So the first step, you can see here, is enter the data. So you know how to do that now. Enter in list 1. Go to stat plot. There you go. The stat plot, make sure you're selecting modified box plot. There are 2. The first one, that's dark right there, that is the modified plot. It has a little dots on it. The one next to it's the regular. Make sure X list says L1. frequency is 1. That means every value in list 1 counts once. And it's zoom 9. When we're doing box plots, we don't play around with the window like histograms. It's usually very good, ready to go. And we see that there is, looks like one outlier
One
there.
outlier.
All right.
There.
Very good. So we're going to copy this graph. That's all we got to do. So once you press trace, we can copy it. Mr. Lewis?
Yes.
I'm pressing trace right now. The minimum is at 64.
Okay.
Oh, that one we could have seen from the picture there. The next value is 67. That's Q1. The median is 68.5.
68.5. Probably right around here.
Very precise. The Q3 is 70.
70.
You want to draw in the box and that lower whisker? Okay, we got most of it. The upper whisker goes to 73. That's the highest value. It's not an outlier. That's next to the biggest value. And then the outlier is at 75. Wow, that was fast.
Yeah, I like that way.
So can't forget how to find the outliers though. Lower fence, upper fence. That's going to be important in problems that come up. So it's not just related to box plots. So you got to remember that rule. All right, next.
Moving on.
All right, Mr. Lewis, this is just read the graph.
Reading the graph.
All right.
All right, we're going to take our 5-number summary from reading the graph. So min would be our lowest number, and that would be our outlier to the bottom right here at 1.7. Okay, our Q1, well, that's where our box starts right here, Q1, that's 2.5.
Oh, that's tempting to do something with that too.
It is, but
You resisted.
yeah, I did. All right, our median right here in the middle line, that's 2.7. Q3 is the other end of our box. That's at 3.0. Got a point. And then our max, ooh, it's not 3.6. It's the other outlier way over here at 4.2.
Okay.
All right.
How
so
about the range? How can you tell the range from the graph?
the range from the graph goes from the max all the way to the min. It's
Yes.
our range of data. So it would be 4.2 minus 1.7.
Yeah, total length. That's 2.5.
2.5. It's our total length of the data. And our IQR goes from Q1 to Q3, so it's the length of our box. So it'd be 3 minus 2.5, and it'd be a 0.5.
All right, Mr. Lewis, what percent of the data lies between 2.5 and 4.2?
All right, well, 2.5 is Q1,
Yeah.
and 4.2 is our max. That's 100%. So if this is 25%, that's 100%. I'm going to go with 75%.
Also, you can add it up 25%, 25%, and 25%.
That could be too.
Very good.
We all have different methods.
All right, Mr. Lewis, how many data items were graphed?
Well, I don't have any idea.
Why
And-
not?
Because it doesn't tell me.
Oh,
This
that-
could be 3 things, or 5 things of data, or it could be 5,000 things of data. I don't really know.
So if they said in the problem statement, we might know, but unless they say it, we can't tell from the graph.
Exactly. So we could just
Bogus.
put, can't tell.
Can we put bogus?
Sure. Bogus.
You get AP credit for that?
I doubt it.
All
Please
right.
do not put bogus on your AP exam.
Okay, so we're ready for the next. So here we go. This is our
Oh.
next topic coming on.
That's a pen.
Comparing box plots. So we want to compare the shape, center, spread, and unusual features for them. So same thing we use to describe them. So the best we can, we compare each feature. All right, Mr. Lewis, I'm going to give you a break here. Just hit that space bar.
All right, I like
Look
it.
at that. So the shape, by the way, we have apparently time in seconds to complete a maze. And so the shorter time, the better. So the data for the girls, the shape is skewed to the right. Looks like it's going up though. How come I say skewed to the right?
Well, because graph's tilted vertically. If you look at it horizontally, the majority of our data
Yeah.
is tilted to the left, so our outlier goes to the right, so we say it's skewed right.
Yeah, so to the right means increasing numbers.
Right.
So since it's going skewed towards increasing numbers, we say it's skewed to the right. Okay, that's why I want to turn the computer sideways.
I've always wanted to do that too.
I don't think it helps them at all.
No, then you're just going to see us in a weird view.
All right, and the males, they're more symmetrical, certainly than the females. So the shape was pretty easy to compare this time. Shape's kind of hard sometimes with box plots. So we just say what we can. Hit it.
All
Next
right.
thing is center.
Center.
What can we say about centers?
Well, the median time for males is just slightly higher. You can look at that. My little
You can also
marker
search.
here.
That's why I included the data down
Right.
there.
So you can look at the median right here because the picture is kind of hard. The picture, they look almost identical. Okay, but the median for the males at 176 here is about 10 bigger than our 166 over there.
The girl's got a little bit of an edge here. So remember, those represent typical values. So kind of the typical girl did a little bit better than the typical guy. A little bit shorter time. Remember, shorter time is better here. All right.
All right, and spread.
We're going to compare IQRs. So the IQR for males is larger than that for females. So it's easy to see in the graph. IQR is the length of the box.
Distance here, distance here.
Now, reading it from the graph, if you have to, you can estimate the values, but here it's nice, we have the data. And so we should say what it is. So for the males, the IQR is just 251 minus 88, and that's where we got the 163. And then for the females, 230 minus 120 is 110. So if you're able to, in your description, give specific values for the median and the IQR.
Yep.
Last, unusual features.
Usual features.
Guess what?
I don't think there is any.
There weren't any.
Oh, okay.
It looked like there could have been an outlier in the females, but it's not. So,
Yep, you don't have to say anything.
yeah, just say no outliers.
Right. Remember, in math, please don't tell us more than the graph gives us.
So, just real quick to remind you, you should state your answers in context usually. So you should say the distribution of times for males and females were, then blah, blah, blah. Compare shape, center, spread, unusual features.
Right.
Okay,
Okay.
it's journal time.
It is journal time.
Got 2 missions here.
Okay. The first, use your TI-84 to create a modified box plot for the mammal speed below. Copy a graph into your journal.
This looks very familiar. I'm not sure if it's the same as the mammal speeds in class. That
Probably.
70 is a cheetah. I don't know if this is exactly the same mammals.
I don't know. What?
We'll find out.
Is that you down there at 11?
Yeah, on a good day. All right, so, and down here, compare these box plots. So this is pulse rates, before and after. I gotta be honest, Mr. Lewis, I'm not sure before and after what.
Yeah. We'll leave that to your imagination.
Yes, but whatever you do, compare shape, center, spread, and unusual features of the box plots. So remember, write in sentences. It doesn't have to be very long. Just a couple sentences explaining that.
All right.
Anything else, Lewis?
No, I think that's it.
Next time.
Okay.